Listen, if you really want to understand the modern technological landscape, you absolutely have to understand the mechanics operating under the hood of artificial intelligence. Welcome to this explainer. Today, we're taking a highly focused, zero-fluff masterclass on the exact anatomy of an AI agent. I'm going to walk you through the absolute core of this technology so that by the time we wrap up, you won't just be a user of AI, you're going to be someone who fully grasps how to command it. We're dissecting large language models, or LLMs, the true brain behind AI agents. You know, it's incredibly easy to treat artificial intelligence like some kind of magic trick. You type in a prompt and boom, a miraculous, highly detailed answer just appears on your screen. But let me be absolutely clear about this. There is zero magic involved here. Every single AI agent operates using a highly structured, strictly mechanical brain. And that brain is the large language model. Whether you're using ChatGPT, Gemini, or Claude, this specific technology is the foundational engine that actually understands your request, generates the response, and powers the entire decision-making process.
Okay, let's dive into this. Here is our roadmap for the masterclass. 1. We'll define the brain of AI. 2. Tokens and context windows. 3. We're comparing the top models. 4. Powering real AI agents. And 5. How to actually choose the right model.
All right, part 1, the brain of AI. What exactly is an LLM? At its absolute core, a large language model is simply a highly advanced pattern recognition system. Now, it has been trained on a massive, almost incomprehensible amount of data. We're talking the equivalent of millions of human lifetimes of reading just to recognize mathematical patterns in human language. And because of this intense structural training, it gains the ability to understand complex questions, generate text, summarize massive documents, translate between languages, and yeah, even write software code. But more importantly for AI agents, it can help with reasoning and planning. It's the thinking engine. But remember this, it does not possess human consciousness. What it possesses is unparalleled statistical pattern matching capabilities.
Let's break down exactly how this brain actually processes a thought. It's a precise 4-step workflow. Step 1, you provide the user prompt. Step 2, the AI system reads the words and the context you've provided. Step 3, and this is the absolutely critical one, it predicts the most suitable next pieces of text based on all that vast training data. It is literally calculating probabilities. And step 4, it rapidly builds those mathematical predictions into a complete, coherent response. You have to understand this. Modern LLMs do not think or ponder the way you and I do. They calculate and they generate.
And this brilliantly illustrates the concept. Imagine a remarkably experienced librarian. Now, this librarian hasn't just read a few hundred books, they have read millions upon millions of them. Because they've consumed that staggering amount of information, when you walk up to their desk and ask a question, they instantly recognize the pattern of what you're asking, locate the precise context, and explain the information back to you perfectly. That is exactly what the LLM is doing with your prompt.
Moving right along to part 2, tokens and context windows, the neurons and working memory.
Here's the thing. AI systems do not read full sentences the way human beings do. They process text in tiny, fragmented units called tokens. A token could be part of a word, an entire word, or literally just a punctuation mark. For instance, if you type in the phrase, "I love AI," the system instantly chops that sentence into distinct computational tokens. It's not reading the feeling of love, it's computing the mathematical weight of those letters. You really need to grasp this, because tokens are the fundamental currency of AI. More tokens mean more information for the model to process, and in the real world, that directly translates to higher computing costs and much longer processing times.
Now, what's really interesting about this slide is the visual of these two desks. This perfectly visualizes working memory, which in AI is known as the context window. The context window is the hard absolute limit on how much information an LLM can hold in its brain at one exact moment. Think of it exactly like a physical desk. A small context window, that's a tiny desk. You can only have a couple of books open before things start falling off the edge. But a large context window is a massive executive desk. You can have dozens of long reports, huge PDFs, and massive coding projects open all at the exact same time. The bigger the desk, the more complex the multi-step tasks your AI agent can actually handle.
All right, part 3, comparing the top models, what we call the AI species.
I need you to look at this landscape completely objectively. Let's be clear. There is no single best model that dominates every single category. There is only the right tool for the specific job. Look at the GPT models. They are absolute powerhouses for general-purpose reasoning and coding. Then you have Google's Gemini models, which are uniquely strong in multimodal tasks and integrating directly into their massive productivity ecosystems. Anthropic's Claude,
widely considered elite for long-form writing, deep document analyses, and incredibly careful, nuanced explanations. And finally, you have open-weight models, like the Llama family. These give organizations the ultimate power to run and completely customize the AI on their own secure private infrastructure.
Which brings us to part 4, powering real AI agents. Let's watch it actually move.
You see, an AI agent doesn't rely on the LLM alone. It actually uses the LLM as the commander. Here's the actual operational workflow. Step 1, a goal is established and a plan is formulated. Step 2, the LLM processes and fully understands the parameters of that task. Step 3 is where the agent actually becomes active. The LLM reaches out, uses external tools, we're talking web browsers or calculators, and accesses stored memory. And then step 4, it executes the action and delivers the final answer. The LLM is the reasoning engine here, but the external tools, they're the ones doing the heavy physical lifting.
Finally, part 5, choosing the right model, myth versus reality. So the crucial point is that model selection isn't just a detail. It is a critical, strategic design decision. You absolutely cannot just pick a name out of a hat. You must ruthlessly interrogate your own use case. Ask yourself right now, is the primary task writing? Does this require heavy software coding? Am I processing massive long-form documents? Will there be image processing involved? Is my absolute priority blistering speed and low cost, or is it deep, methodical reasoning? Do I need it to seamlessly connect to external tools? Your answers to these questions dictate your weapon of choice.
Let's shut down this first fallacy immediately, the myth that bigger models are always better. It's simply not true. The reality is that in highly automated agentic workflows, a smaller, faster, and much cheaper model is often the far superior choice. Look, if you're running an AI agent that just needs to rapidly classify a few thousand customer service emails, deploying a massive, computationally expensive model is a total waste of resources. Speed and efficiency will frequently win out over sheer brute force.
Let's move to the next one and see how this builds. This is the illusion of omniscience, the myth that AI knows absolutely everything. The hard reality here is that these systems have distinct, measurable limitations. They can, and they will, make mistakes, which are often called hallucinations. But more importantly, their internal knowledge has a strict cutoff date, based on when they were trained. To function accurately in the real world, they absolutely rely on external tools and specific frameworks to access recent news, live databases, or your company's private proprietary data.
And to wrap up this debunking sequence, the myth of the universal silver bullet. Let me save you some time. There is no single model that is perfect for every single task. Stop looking for it. The reality, as we've clearly laid out today, is that different models excel in entirely different situations. A truly sophisticated AI workflow often strings multiple models together. They might use a fast, cheap model for initial data sorting and then pass the complex reasoning tasks up to a heavier, much more capable model. Now listen, I don't want you to just sit there and take my word for it. I am issuing you a direct, practical challenge right now to prove the concepts we've just covered. I want you to go to 3 different AI models available to you, say ChatGPT, Claude, and Gemini. Give them all the exact same prompt, create a business plan for an AI startup. Then I want you to be the judge. Compare them aggressively. Which one actually gave you the best structure? Which one demonstrated superior creativity? Which one executed with the best speed? Test the engine, put the brain to work. Until next time, stay focused and keep building.